So this is a standard single-channel measurement demo where we will use the new cross-correlation feature of the FSWX to reduce measurement uncertainty. So in this demo, we are looking at the output spectrum of a high-power PA. What we can clearly see on this screen, which is configured for an ACLR measurement, 100 MHz wide signal in the center in blue, we can clearly see the adjacent channels being dominated by the nonlinearity of the device under test, so clearly shoulders in the spectrum. And I have also activated the so-called alternate channels to the very left and very right hand side on the diagram, which are pretty flat in the spectrum. The question on this ACLR measurement now is, for the alternate channels, do I measure the device under test itself, or do I have a contribution from my measurement instrument, for example through its noise? And in order to answer that question, which is also a question of measurement uncertainty, I will now turn on the cross-correlation for exactly the same measurement. Just on a side note, the current trace we're looking at in yellow is a standard RMS detector power correct measurement in ACLR mode. Now I will open the trace configuration dialog, and I will simply turn on a second trace. And for this second trace, I will activate the new RMS cross-correlation detector. As a result, on the spectrum plot, we get two traces now. Besides the standard RMS trace in yellow, we get a blue trace, which is the cross-correlation RMS detector. What we can already see is, in the alternate channels, we do see a difference between the two traces, simply because there is a contribution from the measurement instrument in these channels. On the right-hand side, the gap between the two channels is significantly, I would guess, something 3 to 4 dB. But in order to get a precise number, what I'll do in the next step is I'll change the configuration of the ACLR measurement so it makes use of the blue trace now. So instead of using the RMS detector for the ACLR measurement, I will reconfigure the ACLR measurement to make use of the cross-correlation RMS detector. All I did is change the trace to be used for the ACLR measurement, and what you can see as a result is significantly increased ACLR numbers for the alternate channel. So by using the cross-correlation detector, we have reduced measurement uncertainty, and we again can show significantly better results for your device under test.